Hey, Mr. Allred here. We're going to talk about differential equations. This is our first talk. Basically, a differential equation is an equation that contains a function as a solution, and it also contains its derivatives. So you might see a y prime, y double prime, y triple prime in its various forms. You'll probably also see x in there as an input variable. But here's some examples. In the first one, we've got 1 minus x times y double prime minus 4x times y prime plus 5y equals cosine of x. Well, of course, x is just a variable, but y here would represent a function. So if we knew what the function y was, and it could be about anything, then that would be set. And taking a derivative would give us y prime, and taking the second derivative would give us y double prime. So whatever function y here, and remember this will be y of x, so it would be some function of x, but we'd just be calling it y. Whatever we had for a function y, we'd have to take its derivative and its second derivative in here, run it through here, and it would have to balance both sides. So we're looking for an expression or a function that would balance this equation. Same thing in the second one, x times the third derivative of y minus the derivative of y to the fourth, and that's an exponent there, plus y equals 0. So once again, this would be if we knew a function y to where we took its derivative and raised it to the fourth power, and also took its third derivative and multiplied it by x, this linear combination would equal 0. So it's not something you would guess. Okay, and these can be very complicated, and there's a whole course for differential equations, but that gives you the idea of what these are. And in this case, if we're just talking about y, the function y, usually it will have like a plus c with it, so it will be like a whole family of solutions. And if we have some initial condition like y of 0 equals 7 or y of 3 equals negative 2, then we can narrow it down to a specific function or equation. Okay. Let's see an example down here. So the first one here I want to go through is just showing you how a differential equation works. We're not really solving anything. So we've got basically f prime equals 3 times f divided by x times the natural log of x. So basically f of x is the function, which will be our solution. F prime is the derivative of it, and when I plug those in, it will have to balance out. And one thing they tell us here is they give us a potential solution, which is 2 times the natural log of x cubed, and they ask us if that is a solution. So the way we'd figure that out is we'd take 2 times the natural log of x cubed and put it in place of f of x, and we'd take the derivative of it and put it in place of f prime and see if the equation on left and right balances out and equals. Well, taking a derivative, we need a chain rule, and it comes out to 6 times the natural log of x squared over x. But when we plug everything in and clean it up, the left and right side do match. So we found an equation, we didn't find it, but we proved that the equation that was given, 2 times the natural log of x cubed, quantity cubed, would be a solution to that differential equation. Okay. Now I want to do one example, and then I'll probably break the rest of the video up into several different videos. But we're only going to do 2 types of differential equations in Calculus 2. And that's separable differential equations and another one, but this video is about the separable differential equations. So a separable differential equation is one that contains a derivative. Usually it's a first derivative, but that's okay if it's not. But we're able to separate the x and the y values. That means the x and the y, what looks like variables, and the dy and dx, so that we can get all the x parts on one side and all the y parts on the other. And there's 3 examples here. And what you'll notice here, dy dx, which is basically y prime, equals x squared times quantity x plus 1. Because this is a multiplier, we can leave the x squared where it is, and we can separate the dy over dx as a fraction and bring the dx to the other side. And then we can divide by the y plus 1. So basically here we're able to separate the y's to one side using division or multiplication and the x's to the other. And then if we wanted to solve this, we could integrate both sides. Okay, we could integrate the left side in terms of y and the right side in terms of x. Okay. So here there are a couple other examples that you can look at and see how we separate. Now it's pretty fair to say that if you were to continue in differential equations, not many of them would really result in separable differential equations, and they're not super interesting, but they are an easy place to start. So let's do one on this video and we'll save the rest for separate videos. So this problem comes from Khan Academy. It's a dy dx equals 6x. So that seems like a very small, simple equation. Now in this one they do give us an initial condition, or at least a condition, and they ask us to find something else. But let's go through solving dy over dx equals 6x. So in that scenario, we can multiply both sides by dx. So on the left side it would cancel out, on the right side it would show up. So in this case, we've got all the y parts on the left-hand side, which is just dy. Now, understand there's a 1 in front of it. And on the right-hand side, 6x dx, which is all x terms. So now that it is y's on the left, we could integrate the left side, which would technically give us y plus c. And on the right side, 6x would integrate to 3x squared plus a different c. But because the two c's on both sides would just be unknown, technically they're different c's until we actually have a value that are not that important. So we could just move them both to one side and say it's one cumulative sum called c. So you might think of it as a c1, a c2 on each side. We just combine them to be c. Since we haven't really specified what those constants are, we can just go ahead and collect them into a single one. So this right here, y equals 3x squared plus c, is called a general solution. It is not pinned down to a very specific place. But this is a solution, and we could kind of throw it back in the original equation and see if it balances both sides out. Now they also gave us something here, y of 2 equals 8. They gave us that in the beginning. So we could use that, and we could actually figure out what the c is. So we could throw in 2 for x and 8 for y, and if we solve it, we'll get -4. So now we have y equals 3x squared minus 4. This is called a particular solution because it actually goes into, meets a specific condition. So it doesn't have that constant open over here to interpretation. So this is pinned down to a very specific spot. Now, to answer the last question they had up there, which is a very simple one, now that we've got the particular solution, it solves a differential equation and it goes through a very specific point that they put out there. We could find the y of 4, which just means we plug in 4 for x. If we run that through, y equals 3x squared minus 4, we get 44. Okay, so we learned a little bit about what a differential equation is. We learned about separable differential equations, and we actually solved one. To keep these kind of short, or at least within reason, I'll solve the other ones in this document separately. Thank you.